Hey everybody, Omni-Griffin here, and welcome back to the Human Resource Machine. So, we are going to be doing the easy route today, because I'm feeling a little sick, and yeah. I got a little bit of a cold. Hopefully I won't sniffle too much. But yeah, we're just going to do this one. I don't actually know what it is. Yes, we believe in educating our employees on the job here. Do you know what a zero terminated string is? Oh, yeah, okay. It's a very old technique, and we don't expect you to know. Oh, man, that means I'm old. Okay, so you may ask me about if you like, or you may ask an external source. Whatever helps you get the job done. The inbox is filled with zero terminated strings. What's that? Ask me, your boss. Add together all the numbers in each string. When you reach the end of a string marked by a zero, put your sum in the outbox. Reset and repeat for each string. So basically, a zero terminated string really has more to do with letters than it has to do with numbers. I understand why they're using numbers here, because they don't have anything to do with letters, because they're strings. They want us... Numbers give us something to do with it, because all we're doing here is manipulating them via math. So we could add, we could subtract, we could do whatever. In this case, we're adding. Zero terminated strings are basically just saying, hey, this zero means we're done. And that's how a computer could tell the difference between, look at memory and understand what it was looking at. It's so that you didn't have to say, hey, here's a string, it is 10 characters long. You could say, here's a string, it runs until you hit the zero, then terminate the null character. Yeah. Whatever it gets called in whatever lesson you get learned, or you get taught. So, we're going to have two jumps here. One that is in here, and one that is in here. So we're going to have an outbox here. And these aren't going to be jumps, they're going to be jump if zero. This one's going to be a jump if zero. So we'll do it. Alright. I'm going to presume that there are no double zeros. We're going to find out if that assumption is correct. I could write the code that would check it, but since we're going to be looking to optimize, I'm going to not 100% do that right off the bat. We might find out differently, but we'll see. So, obviously, right from the get-go, we're going to inbox. Before we do anything, we need to... running total. Yep. It's a running total. So we're going to copy from 0 and copy to the running total. And then we are going to, before this outbox, copy from the running total. Because we're going to inbox here. I just want it to be clear that it's a 0. Because we're going to inbox here, and then if it's 0, we're good. Alright. We are going to inbox once here before the loop, because the last thing we do in this loop is going to be inbox. So... Actually, I suppose... if we are presuming that there are no double zero strings, this will always be true. Because we're going to be adding to 0, thus it's going to be our first one. And this will also save us one instruction when looping back, because the inbox at the end will hit what we're doing. Alright, so, copy to running total. Right, and then... oh, we actually don't want to do that. Darn it. We do want what we had before. Because otherwise we have to do other silly things. Right. So, we're going to add that to the running total, and then we're going to copy it to the running total. And this should actually work, I believe. I believe this will work. So let's step through it and watch. So we are setting up our initial conditions for the loop. Boom. We start with 0. We inbox. We add it to the running total. We copy it to the running total, and we inbox. Is it 0? Oh, whoopsie. Shoot, no. We want to jump if not 0. That's annoying. This is going to be simplifiable, actually. We can do this. We can do this now. Yep, that'll work. And this will actually handle the double zero case, which is dumb, but because we don't need to handle it, I don't think, but whatever. Alright, so we set up our initial conditions, and then we inbox. Is it 0? No. We add it to the running total, and copy it to the running total. We inbox. Is it 0? No. We add it to the running total. We copy to the running total. We jump. We inbox. Is it 0? Why, yes it is. We copy from the running total, and we put it in the outbox. Okay, we are going to have a double zero case. So, good. Good, good, good. Let's go ahead and speed this up. So we have to once again start over with a 0 in our running total. 9. Cool. -7. So we're at 2. 5, 7. Oh, look, a 0. We put a 7. Cool. We copy from 0, we put it there. Is it a 0? Why, yes it is. Oh, look, another 0. Oh, and then we have a very large string, which I'm just going to play through. As you can see, this is working just fine. Beautiful. Yay! Nice, we're at 10 commands. And our speed challenge is a little long. Okay, so that's cool. We got our size challenge right off the bat. So, can we make the speed better? Yes, we can. We actually can. It's dumb, but we can. So how are we going to do it? Well, first off, we inbox here. We jump if 0 straight to the outbox. If it's a 0, that short circuits the entire thing. Bam, done. Otherwise, we copy it to the running total. Then we add we still need the inbox there. This will shortcut a little bit. So we're gonna go ahead and, we were at 92 before. We did save maybe 10 steps, I think, by adding that, but we also added in quite a few. I knew that was gonna happen. Oh, we hit it on the nose. Wham, bam, thank you, ma'am. That was an 8-minute optimization. Cool. Sometimes just the littlest things save you a lot of time. The littlest number. We can do another one. I think we've got time. To reduce our carbon footprint, management is requesting the smallest numbers only. This is a public relations exercise. The results are going straight to the landfill. For each 0 terminated string in the inbox, so we're doing 0 terminated strings again, send to the outbox only the smallest number. If you've seen in that string. You will never be given an empty string. Reset and repeat for each string. Okay, so we no longer need to worry about having 0 as our first thing. Great. So like before, we're going to have 2 jumps. One for the inner loop and one for the outer loop. The inner loop is on each actual string. The outer loop is through all the different strings. You can think about this as actually a 2-dimensional array, funnily enough. Otherwise known as a matrix, a grid, whatever you want to think about it. It's basically an array of arrays. That's how we're being presented our data. And we have to basically iterate through that in the proper way. So, how are we actually going to do this? Well, the answer is going to be pretty simple. So this is going to be smallest with an asterisk, because that asterisk is thus far. And this is going to be current, i.e. the current one that we're checking. Now, when we inbox the first time, we're going to straight away copy it to the smallest. Like, that's it. We're good. Like, we're good. We're just good at that point. That is the smallest thus far, guaranteed. We then input. If it's a 0, we're going to jump here, where we copy from the smallest and outbox. And then jump back to the start. Oh, no. And jump back to the start to start all over again. Relatively simple. Now, if it's not 0, we have to do a little bit of figuring out. So, let's kind of run through this in our head, right? We're going to copy it to current, because it's the current one that we're checking. And we need to save it because we're going to modify it to check it. So, but let's just use the example that we have here. We have 6 here, and we'll have 11 in current. And we're currently holding on to current. So what we want to do is we want to subtract the smallest. Yep, subtract the smallest. So that means that if the smallest is smaller than our current, we'll have positive. If it's not, it's negative. Exactly. That means that we want to jump if negative, and we're going to have to jump to here and then jump back in. There's not much choice that we have there. I don't think we can fall through properly, but we'll see. So if it's negative, that means that our current one is smaller. So then we're going to copy from current and copy to smallest. This should work. Let's check it out. So we're going to step through. Take our inbox. Well, 6 is the only number we have, so it's currently our smallest. So we inbox. We copy it to current, and then we subtract smallest. It's not negative. That means it's not useful. So we inbox again. We copy it to current, and then we subtract the smallest. Hey, look, it's negative. So we copy from current. That's why we had to save it in current, because we are basically destroying the number to check. And we copy it to smallest. Up, it's a 0. So we copy from smallest. We outbox. We start over. Beautiful. That looks like it is going to work just fine. So let's run through it real fast. So we can expect that this will be 1. So we're going to see 1 and what appears to be 26 probably. Yep. 26 is the answer. Beautiful. Worked like a charm. Now let's see. Yeah, we didn't get that. Oh, we're really close though. So we didn't get either in terms of optimization, but I have a feeling that if we look at this again and try and do a little bit of that optimization, we might be able to get both of those fine. So I don't think we have anything to lose in terms of the number of stuff that we're doing. Now, we could... Could we? We can't put a 0 in here, so we actually have to start by doing this. Absolutely must. We have no choice. We have to copy it to the smallest. So we can't change this. What we can change is this in here. We've got a lot of jumps that aren't very well optimized. So what I'm actually going to do here is I'm going to clear this out. This is very simple. This is a very simple algorithm. What we need to do is we need to perfect the inner loop. The inner loop is what we need to perfect. So we already have the inbox, the copy to smallest, and the jump here. I'm basically just ignoring the outer loop for now. We know we constantly want to jump. So, but when we inbox here, we need to jump if 0, and we need that out. We need that to get out of this loop. And we need to subtract from the smallest. Now there is a copy to current in here. And then jump if negative. The question is, where does this go? Because this needs to go somewhere. The question is where. Is there any way we can optimize this? We can't jump if positive. Jumping if positive would be the best thing we could get, because then we could put it back up here. But that's not the case. Yeah, see, this still requires the jump back, which is what we're trying to avoid, because that is copy from current, copy to smallest. And we don't really have a way, because when we jump out if 0, we absolutely must copy from smallest, then outbox, and then jump. So this is exactly what we had before. Turns out, this is exactly what we had before. The key is that jump. The key is that jump if negative. So how do we do it? How do we make that jump if negative work? How do we make it work better? Is there any way? Because if we always copy from current and copy to smallest. We want to skip that if it's positive. This is a debate. So, sorry, I'm mulling things through in my head. So, this jump if negative, this is our problem. Because it requires an extra jump. Inbox. If it isn't negative, we want to do it again. So we want to inbox, copy to current, sub smallest, I think I figured it out. But this is going to be a little odd. Because there's... oh god, because it could be negative. If any of these first numbers is negative, this breaks. I feel like noting this. So, this will work. We'll have a inbox copy to smallest here. If this is negative is the problem. Or do we front load the first part of the loop? Well, either way, this jump if 0, we copy from current, no, sorry. Copy from smallest, we outbox, and then we jump. So this will work, but it's a little weird, I think. Let me double check. So we inbox, we copy the smallest, check. All right, if it's negative, we jump. Here. Because that means it's not worth it. Which jumps us all the way back. Oh, then we hit an infinite loop. Oopsie. Darn it. Darn it, darn it, darn it, darn it, darn it. Crap. I thought building this loop the other way around would be clever, and it kind of almost worked, but not quite. So let me show you the problem. What will go wrong here, and that might actually help me figure out how to make it be right. So we inbox, we copy to smallest. Cool, we've got 6 here. We jump if negative. We don't, because it's not negative. So we inbox, we get 11. Is it 0? No. So we copy it to current. Then we subtract from smallest. We get a positive number. We jump. It's positive. Cool. No. Yes. So we don't want to do anything because it's bigger. Darn it. No, this doesn't work. This doesn't work. Ah. And then we end up in the same place. Problem is we end up in the same place because we have to copy from current and copy to smallest. And we're back at 14. Ah ha ha, you fiends. Okay, so there's something here I'm missing. I think I know what it is. Okay, I think I got it. I think I got it. Excuse me. All right, maybe I've got it. So here, I'm just gonna clear this again because clearing it works. All right, so what I'm thinking is we inbox. We copy to smallest. We copy to current. This is actually going to be a step optimization, not a number count optimization. Copy to smallest, we copy it to current. Actually, this might end up being... Yeah, alright. So then we have our loop. That's that loop. Because then we inbox. We jump if it's 0 to our copy from smallest outbox. Right. If it's not 0, we want to continue. So we copy to current. No. Right, we copy it to current, and then we subtract from smallest. Okay, I think I might have figured it out, but I'm still going to finish walking through here. So, we copy to current, we subtract from smallest. If negative... Yeah, no, this doesn't fix anything. Alright, so... Sorry, I just realized that I was building the exact same code again. Sorry about that. I tried to aim away from the mic. Hopefully it wasn't too loud. So, we're going about this the wrong way. Go figure, right? So, when we inbox, we are going to copy it to the smallest. And then when we inbox again, we are going to copy it to the current. But then, we are going to copy from smallest and subtract from the current. This changes the paradigm. This changes what we're expecting. Before we were subtracting smallest from current. Now we're subtracting current from smallest, or the other way around. I honestly don't remember which way the subtract command actually works. See, watch. Here. Hey, look, it's negative. Don't change anything, right? This is still smallest. Don't change anything. That's what we want. We want the copy of negative, or the jump of negative to be nothing happens. See? There we go. Now, if it isn't negative, that means we found a new one. New smallest. So we copy from current and copy to smallest. And then we jump back. Less loops. Also, we add in our jump if 0 to our inbox here, which copies from smallest, copies to, or outboxes, and jumps. Now, we still end up with 14. Why? Because of this shenanigans. There might be a way to get rid of this, but I want to make sure that this works. Copy to current. Oh. No, never mind. That was just a fluke. Right. Okay. Okay, this totally works. Where does it rate? It works, but there has to be a way to make it better. Dang. So we actually made it worse in every way. Oh, lovely. That's silly. But it's, you know, it's my own fault. Alright, so we're aiming, obviously, here for code, for the number of lines here. That has to be what we're aiming for here now. Alright, so we know we're not going to have a 0 string, so we don't have to have a jump 0 there. We always have to inbox them. We always have to copy the smallest. Is there any way... Is there any way to reduce this? Is there any way to reduce this? We don't have any way of checking if things are null or anything like that, so we can't just blindly inbox and do this because there's no 0 here, and we don't have a way of putting a 0 there, which sucks. But that's okay. We'll deal with it. So, we basically traded an extra jump for this extra copy from. Because we now have to pick up the smallest in order to switch these around. So... Man. This one's tough, actually. I'm impressed. I'm glad. We have to do this, we have to do this, and we have to do this. Like, these are necessary. There's no way we can do this without them. There's no way we'll randomly be holding the smallest. Because we all just inboxed a 0. And that's the only way we can check that we're at the end of the string is by inboxing a 0. Only way. So, this inbox, jump if 0, copy from outbox jump, all the way back to the start, must happen. This initial inbox must happen. There's no way we can get around it. The initial copy to smallest also must happen. There's nothing else we can do about that. Alright. Then the next inbox must happen. And we've got this jump if 0. So, the big things are everything in the loop. The inbox has to be first in the loop. It absolutely must be the way that we're doing it now. There might be a way to do it differently, but it'll be more lines of code. Like, we could put the inbox, like, down at the bottom or something weird and jump around. We could maybe do that. Man. Trading a copy from for a jump and or vice versa is not what I expected to have happen there. I do like this better. This is more elegant code, for better or worse. It's also slower code, but that's because we're doing some extra stuff in here. I think I know how this is going to go for the optimizing the number of steps, and I'm not looking forward to it. But that's okay. I'm trying to optimize the other thing. So, if we jump if negative back to the start, there's not much we can lose here. This jump has to be there, because it falls through here. Darn, almost. Oh, wait. There you go. This is dumb. Don't get me wrong. This is dumb. Don't write code like this. But we're optimizing out one thing. So basically, we had a copy from current, copy to smallest, and then we're jumping to here. So yeah, this will work. I don't like that it'll work. It's taking advantage of two lines of code that are not logically in the same place. Like, we're doing that copy to smallest because the first copy definitely wants to be a copy to smallest. This will still be 89. This copy to smallest is in this code for a different reason than the copy to smallest here. I want to make this excruciatingly clear. These two copy to smallests are completely different in terms of why they are logically in this code. The fact that we can remove this one and take advantage of this one being there is pure happenstance based on the way that the algorithm is working. This is bad code. As somebody who writes code professionally, this is bad code, because code nowadays, where your code is doesn't matter nearly as much as it used to. The reason why older languages such as C and C++ and obviously others, those are the old ones to me, okay? I'm not the oldest person ever. Have memory management, very specific memory management, because the amount of memory that you used when you were coding with those programs, when they were created, those languages, it was very important. Remember, megabytes used to be $1,000. Gigabytes now are $100, and they're becoming cheaper. They're probably cheaper than $100. I haven't bought a new hard drive in a little while. They're probably cheaper than $100 now for a gigabyte. And soon it'll be the same thing for a terabytes are $100. Gigabytes are 10 cents in a hard drive. So, and soon petabytes, the next thing up from terabytes, will be the same thing, like $100 for petabytes of data. Eventually it'll slow down, but for now, or at this point in time in history, the vast majority of the code you write isn't going to matter how big it is. This one line of instruction is not worth what you sacrifice, and what you sacrifice is clarity. Somebody who looks at this code isn't going to see this right away. They're going to see that, oh, you're doing this, and you're copying from current, and then you're jumping back. They may notice this, and it may make sense, but it's going to take them extra effort, extra cognitive effort, and much more careful reading of the code to understand what the code is doing and how it's doing it. So, don't do this, because what's going to happen is, in just the fact that chances are you're going to put the code that you're putting into a program, you're going to write it, and you're going to be done with it because it's going to work, and then you're going to leave. And you're not going to touch it again for a while. The person who needs to recognize the code might be you. It might not be somebody else. Somebody else might show up and be like, oh gosh, what's this code doing? I need to fix this. There's a bug here. You're busy working on something else that's important. I'll fix this bug. Oh gosh, what have you written in this code? Why does this make no sense? What is this? Why is it doing this? Why not just do it this way? Why not do it this way? And that's the reason. Because this way is more readable, makes more sense, and logically, it will be much more forthcoming to the person that's reading it. Now, granted that you're not writing in this code. These instructions are flawed because they're purposely limiting what you can and can't do. So, now that I'm done with that rant, I do apologize. Code readability is very important. I've worked with systems that the code is over 10 years old. And being able to understand what somebody is doing, like why they wrote the code they wrote 10 years ago, is a very hard thing to do. So code readability is a very important thing to me. And now that I've been on that rant, I need to take a sip of water here real fast. Okay. So how are we going to optimize this in terms of instructions? Well, answer number one is A. This is my guess. I don't actually know this is going to work. And B. We're kind of going to create a little bit of a state machine here. We're going to inbox, we're going to copy to A. We're then going to inbox, and we're going to copy to B. And then we're going to subtract A. Here's the thing. I'm not labeling this one smallest and not labeling this one current, because which one is smallest is going to change. That's right, this is going to be a little odd. So, and by a little odd, I mean it's going to be very odd. Because we don't care about the number of instructions, we care about the number of... Well, we don't care about the number of instructions in the code, we care about the number of instructions that get run. And we're going to optimize by not presuming one over the other, I think. I could be wrong, but I think this will be good. Or front-loading a loop might be the way to go, but I want to try that last because I find that to be a little less interesting solution attempt. So, we sub A. What's going to happen if this is negative? If this is negative, that's going to mean that B is bigger than A. Let me double check my logic here. The sub command, it always messes me up. Alright, it's positive. That means A is bigger. So, right here, A is smaller. A small. B small. Yep, this is going to be a little weird. So, what do? When we know that A is small, we inbox. And we're going to have jump if zeros here. Maybe. We'll deal with that in a little bit. We inbox. We copy to B. We sub A. We jump if negative to B small. Otherwise, we jump back to A small. Does that make sense? I hope so. Because I need to write it for B small. You'll see the difference here real shortly. We inbox. We copy to A, because we know that B is smallest. Then we sub B. If it's negative, it means that A is now small. Making sense? I hope so. Alright. Otherwise, we know that B is still small. Is everybody following thus far? Here, we'll watch this in action. Now this is gonna blow up. Oh yeah, here, we'll do our jump if zeros here. This is gonna be hard, by the way. Copy from B. Outbox. Jump. And this one will be copy from A. Outbox. Jump. Alright, let's watch this shit in action. Because this could be interesting. This might totally fail, by the way. So we inbox. We copy to A. I'm gonna speed this up here. We copy to B. We sub from A. Hey look, it's not negative. So that means A is the small one. See? 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 A is the small one. Oh shit, calm down. I wanted it to... Dang it. I realized I wanted those organized like that. Anyway, so yeah, we have to do this again. Full speed. So 7 and 11. Subtract that. So A is small. We got that. We inbox. It's not 0, so we copy it to B. Then we sub A. It's negative. Guess what? That means B is small. We inbox. It's a 0. Copy from B. Output. Start over. Make sense? We are flip-flopping the two. We keep track of... We basically hold on to a state. Instead of having one loop that then copies back on itself, we instead have two loops, one of which is when this one is big, or this one is small, and one when this one's small. This may not be more efficient, but it's a very cool... I think it's cool. I like it. So. Boom shakalaka. So, obviously we blow this out of the water. How do we do on the speed challenge? Yeah! Oh, look at that! We beat it by 10! That's the way to do it. Alright. So, I hope that all makes sense to you. By keeping the state, we do less memory copying. You'll notice that here, copy 2s only occur by themselves, and copy froms only occur at the end. Because we know which one's smaller, and we're storing it in a state, kind of, by which loop we're in. Which loop we're in tells us which one we think is is the smallest. By storing that state, we don't have to do a copy from current, copy to smallest. And that actually saves us a lot of time. And also we save a little bit of effort because we don't have to deal, like this jump if negative is being manipulated as we want it to be, which is by jumping to the other loop. We don't have to worry about, oh, well, if it's negative, we do nothing because it just runs right back through the loop. But if not, we have to do something else and then go back to this loop. We just go straight into the other loop because we no longer have to worry about copying stuff around, which was that 2-step in between we saved for every single step in between. Cool? Yeah? If you have any questions at all, please put them in the comments section below. I love this stuff. This game is killing me with awesome, and I am absolutely enjoying it. So much so that I will watch this again. So we get the little children yelling yay as I say thank you guys very much for watching. I hope you enjoyed this episode. I will see you next time, but until then, keep your gears turning.